Okay, so let's look at Unit 2, Lesson 3, the distance from a point to a line. And before doing so, I'm going to start with a little bit of a review of how to find the point of intersection of two lines, which we will need for this lesson. So here I have two equations. Here's equation 1 and here's equation 2. I need to find the point of intersection. I'm going to use an algebraic method, and I'm going to start by taking the first equation and isolating for y. So if I have 5y on the left and I move the other two terms on the other side, I would have negative 3x plus 4. Then if I divide both sides by 5, I would have y equals negative 3 over 5 x plus 4 over 5. Now, I'm going to take this equation and substitute it into equation number 2 so that I can replace the y variable with the equivalent expressions. So here we go. I'm going to have negative 3 over 5 x plus 4 over 5 equal 1 over 2x plus 4. Then I'm going to collect the x terms on one side and the other terms on the other. So if I bring the x terms to the left side, I'm going to have negative 3 over 5x minus 1 over 2x equal to 4 minus 4 over 5. Now it's difficult to collect the x terms because they have a different denominator for each term. So I'm going to find the common denominator. So the common multiple of 5 and 2 is 10. So I'm going to use 10 as the denominator, which means I have to multiply this fraction by 2, the top and the bottom, and this one by 5. So here I'm going to write negative 6 over 10 minus 5 over 10. Sorry, these are x terms, so I have to do negative 6 over 10x minus 5 over 10x equals, on the right side, a common denominator would be 5. So 4 can be written as 20 over 5 minus 4 over 5. Now, negative 6 over x minus 5x is negative 11 over 10x. And on the right side, I have 16 over 5. And now to solve for x, if I multiply both sides of the equation by 10, I would have negative 11x equals 32. And if I divide both sides by negative 11, my final result for x would be x equals negative 32 over 11. And you leave it as a fraction. And that's already in its lowest terms. Now, to find the y variable, I go back up to the equation I have up here, and I substitute my x and solve. So negative 3 over 5x, which is now negative 32 over 11, plus 4 over 5. And if I multiply out these fractions, I have positive 96 over 55 plus 4 over 5. And I need a common denominator to add these two together. So 96 over 55 plus multiply the top and bottom by 11. And I get 44 over 55. 96 plus 44 is 140 over 55. And that can be reduced to 28 over 11 if I divide the top and bottom by 5. And so my y variable is 28 over 11. Therefore, the point of intersection is negative 32 over 11 and 28 over 11. So that's just a quick review of how to use substitution. Now let's move on to what I want to accomplish in this lesson. So here's example 2. How do I find the shortest distance from a point to a line? So here's the example. Determine the shortest distance from the point 5, 2 to the line represented by y equals 2x plus 1. Use a diagram to check your answer. So I'm going to start by plotting the points and drawing the line. So here's the point 5 and 2 right here. Okay, and I'm going to draw the line y equals 2x plus 1. So I'm going to start from my y-intercept of 1. The slope is 2x, so my next point would be here, then here, then here. And I'm going to use a ruler to connect my points, and I'm going to draw that line. Hopefully I can do it accurately. Uh, okay, something like that. Now, what is the shortest distance from this point to the line? Well, it's going to have to be a perpendicular line, right? That's going to be the shortest distance. Now, uh, it's going to be like you can't just have, it has to be a line. Draw the shortest line you can. It's going to be at a 90-degree angle. You can't draw it this way because that's too long. You can't draw it this way. It's going to be also too long. It has to be a line that's perpendicular. Now, if you go with that, uh, if you follow that rule, then you can systematically find your way to find that shortest distance. So I'm going to write a couple of steps here. So let's write down step one. So step one says determine the equation of this perpendicular line. So again, the upside down T means perpendicular line. So perpendicular line using the perpendicular slope and the point. And which point? Point 5, comma 2, because that point is going to be on that perpendicular line. Now, what's the perpendicular slope? Well, I already know the slope of the first line, so that slope is 2. So the perpendicular slope is just a negative reciprocal. So you flip the 2 into a fraction of 1 over 2 and make that positive into a negative. So using the equation of the line y equals mx plus b, I'm going to write my slope. So y equals negative 1 over 2x plus b. Substitute the point 5 and 2 to find my b value. So 2 equals negative 1 over 2 times 5 plus b. And if I solve for b, b would equal 9 over 2. And therefore, the equation of the line is equal to y equals negative 1 over 2x plus 9 over 2. Now, the next thing I need is to find the point of intersection, because I need the other point, because you can't find the distance unless you have 2 points. So to find the distance between those 2 points, I need that point of intersection where these two lines meet. Now I can also now show you the draw the rest of the line. So if I draw the rest of the line, I can properly show you that this is the perpendicular line I'm looking for. And here we go. Okay, and just show the 90-degree angle like that. Now, what's the point of intersection? This is why I reviewed the first example, because I need to use substitution. So here I'm going to take, so write down step number 2, determine point of intersection. So I'm going to take my equation for the perpendicular line, negative 1 over 2x plus 9 over 2, make it equal to the equation of the first line, so 2x plus 1. So what I've just done is substituted the y values with their equivalent expressions. And I have an equation where I just have x, and I'm going to solve for x. So 9 over 2, if I bring the numbers to the left side, so 9 over 2 minus 1 equals 2x. Bring the negative 1 over 2x over, it becomes plus 1 over 2x. And now I collect like terms. 9 over 2 minus 1 is the same thing as saying 9 over 2 minus 2 over 2. And on the right side, I have 2x plus 1 over 2x, which is just the same thing as saying 4 over 2x plus 1 over 2x. So I can have a common denominator. And so 9 over 2 minus 2 over 2 is 7 over 2. And on the right side, I have 5 over 2x. 2's cancel each other out. And x, if I solve for x, I get 7 over 5. So there's my x coordinate. Therefore, the y coordinate right here, y equals 2 times 7 over 5 plus 1. and that equals 19 over 5. So there's my y value. I have my x value, okay, and I'm one step closer to finding the shortest distance. Now I'm just going to write a quick little note here. Let's put a little star. The perpendicular line from the point 5, 2 to the line y equals 2x plus 1 will be the shortest distance. And that's always going to be the case. The shortest distance from a point to a line is the distance that is perpendicular to that line. Okay, and I'll maybe bubble that. Okay, and so maybe I'll also indicate that this symbol means perpendicular. Okay, so let's continue. Step number 3. The step number 3 then is just to find the distance between the 2 points. Okay, so use the distance formula. Okay, we're going to take the square root, put everything under the square root in your calculator. So here it is, the difference in the x value, so 7 over 5 minus 5 squared plus the difference in the y value, so 19 over 5 minus 2 bracket squared, and put that into the calculator and solve. What you'll end up having is 81 over 5 square root, and when you simplify that, you get 9 on the top, and you still have the square root of 5 on the bottom. Or if you're using your calculator, that will approximately equal to 4.02. And that's the distance of from the point 5 and 2 to the line y equals 2x plus 1. Okay, let's do another example. Okay, example 3. A ranger cabin is to be built in a flat wooded area near the straight road that connects 2 campgrounds in a park. A new side road will connect the cabin to the campground road. On the park map, the campgrounds have the coordinates A and B, while the site for the cabin is R. Each unit on the map grid represents 500 meters. So, part A, find the route that minimizes the cost and the number of trees that have to be cut down for the side road. Draw a diagram of this route. So you can imagine this whole area is wooded and has lots of trees. You don't want to cut that many trees, so we need the shortest route possible. Okay, so therefore I'm going to write here the shortest route will be the cheapest route, because you don't have to cut as many trees, right? The cheapest route. And so therefore we need the shortest route, which will be the perpendicular, something perpendicular to the road. Okay, so that means I'm going to go from my cabin site and draw a perpendicular line, and that's going to be the shortest route to that road. Okay, so that means I need to find the slope from A to B. So A to B is represented by that line segment, and the slope of that line, I'll use the slope formula. So the slope from A to B equals y2 minus y1 over x2 minus x1. So if I substitute the coordinates that I was given, I would subtract 4.5 minus 8.5 divided by 10 minus 2. So basically b minus a. Simplifying this, I get negative 4 over 8, which is equal to negative 1 over 2. And the perpendicular slope would just be the negative reciprocal. Okay, so the negative reciprocal is flip the fraction 2 over 1, change the negative to a positive, And so it's going to be the perpendicular slope would just be 2 over 1. I can simplify it to just be 2. Okay, so there it is, 2. Next, I need the equation of the line. So I need the equation of the line AB. So let's find AB. And the reason I need the equations of both lines so I can find their point of intersection, right? So the equation for AB is y equals mx plus b. It's a line, so I need the mx plus b. I'm going to use point A. And point A is 2.0 and 8.5. And I know the slope is negative 1 over 2. So if I put that into the formula, so 8.5 equals negative 0.5 times 2 plus b. Solve for b. So 8.5 equals negative 1 because that's half of 2 plus b. And therefore b would equal 9.5. And so therefore the equation for AB is y equals negative 1 over 2x plus 9.5. Now I need the equation for the perpendicular line. So let's give the point of intersection here a label. We'll call that D. Remember, B is over here. Okay, so the distance from R to D, again, it's a line, so we're going to use y equals mx plus b. And I'm going to use the coordinate for R. R is 6.0 and 1.5. And the slope is equal to 2. So let's plug those values in. So 1.5 equals 2 times 6.0 plus b. And 2 times 6 is 12, so 1.5 equals 12 plus b. And if I solve for b, b equals negative 10.5. So therefore, the equation for my perpendicular line will be 2x minus 10.5. Now, I have the two equations. The next thing I need to do is determine the point of intersection. Determine point of intersection. And the point of intersection, when I put those two lines together, looks like this. So negative 0.5x plus 9.5 equals 2x minus 10.5. Collect terms like terms on each side. So here I'll have 9.5 plus 10.5 equal to 2x plus 0.5x. And 9.5 plus 10.5 is 20. And 2 plus 0.5 is 2.5x. Divide both sides by 2.5. And you get your value for x. And x turns out to be equal to 8. Or you could say 8.0. Then you substitute it back into one of the original equations. So y equals 2 times 8 minus 10.5, and that's equal to 16 minus 10.5, which is equal to 5.5. And so therefore, the point of intersection is 8 and 5.5. And that's point D. Let me write it properly. So I'm going to say here point D. I will use 8.0 and 5.5. Okay, good. So now that's the first part. The next part is find the length of the side road. So I need to find the distance from R to D. So let's write here. So the point of intersection of the two roads is point D, which is 8.0 and 5.5. And the best route is the line joining point R, which is 6.0 and 1.5, to point D, which is 8.0 and 5.5. Okay, so to find that length, I need to use the distance formula, and that's given by x2 minus x1 squared plus y2 minus y1 in brackets squared. So let's plug in our values. X2 is going to be 8.0 minus x1, which is 6.0, square that, plus y2, which is 5.5 minus 1.5 in brackets squared. All of that under the square root sign. On my next line, I'm going to have 2.0 squared plus 5.5 minus 1.5 is 4.0 squared, all under the square root sign. 2 squared is 4, 4 squared is 16, 4 plus 16 is 20, and the square root of 20 is about 4.5 approximately. So we are also, that's 4.5 units. We're also told in the question, if you look carefully, that each unit on the map represents 500 meters. So I have to take that into account. So if 1 unit equals 500 meters, then 4.5 units equals 500 times 4.5, which is equal to 2,250 meters. So therefore, the shortest distance, or that short road, is 2,250 meters long. And that's how you solve this example. And that ends this video.